I created a PCB called, lovingly, the Very Bad Board. I did a sample design review on this board, and all of the issues baked into the Very Bad Board are extremely common, and I tend to see them in every single design that I review. So let's quickly touch on just 4 of these common issues that are in the Very Bad Board that I see everywhere. The first thing I look at in a PCB, and what I consider to be the most important part, is the stack up. This is probably the most important, yet it's overlooked. In the Very Bad Board, 4-layer stack up was used that is right off the shelf from a fabricator. However, it's not great for this design for the power impedance and the signal returns. So in the review that I did, I suggested a new stack up, 8 layers. This gives you a very low impedance on the power and very good returns for all your signals. The second issue that I see all the time are return path discontinuities. So switch signals on a PCB are going to return on whatever copper is nearby. It doesn't matter what that voltage is. So if we consider a trace in a PCB, the return is always going to be in the planes right below or right above, depending on where that trace is. So if your return path has a break in it, that current is going to spread, and it's going to cause a lot of issues. It's going to cause long distance crosstalk, EMI, intersymbol interference, and a lot more. Third is terminations. Almost all modern digital is going to need terminations of some sort. The general rule of thumb is if your trace is longer than in inches than 2 times the rise time in nanoseconds, you need to treat it as a transmission line. In modern digital, 1 nanosecond is pretty common. That means anything longer than about 2 inches needs to have termination, or you're risking ringing an EMI. In the Very Bad Board design, we see that, for example, in the oscillator, there are 2 traces leaving that oscillator without terminations. So not only are we going to have ringing, we're going to have stub-induced noise as well. The fourth is decoupling. I've noticed that decoupling is a topic that is so commonly misunderstood that we designers tend to just use these rules, like place a 1 microfarad and a 0.1 microfarad in parallel on each power pin, or something similar. These rules may appear to work in the design, but it's not guaranteed that it's always going to work. One small change to your code could completely ruin that decoupling that you have. So proper decoupling is much more involved, and we can see on the Very Bad Board, the decoupling is very poor for many reasons. The mounting is really bad, the way that we mounted the capacitors to the board. The geometry of the capacitor is too large, and the connections to the IC are too high impedance. So we've covered quickly 4 of the most common issues that I tend to see in PCB designs. There are many more considerations, which is why it's obviously very helpful to have an expert weigh in on your design. I am currently updating the Very Bad Board. I'm splitting it into 2 projects, the good PCB design and a bad PCB design. That way, it's much more complex. We can dive into the bad areas of design and how you can improve them in a good design. So stay tuned for that.